For half a century, one fossil defied every attempt to explain it. It seemed to mock science itself, an ancient imprint, so alien that even seasoned paleontologists whispered that it might not be from this world. It was twisted, soft-bodied, with no clear head or tail, no bones or shell, no features that fit neatly into any known category of life. It looked like something from the dreams of another planet, a riddle carved into stone by time. And for 50 long years, no one could tell what it was. The fossil was found in the 1,950 seconds, deep in the shale of a Midwestern quarry that had once been a shallow sea. The rock came from the late Carboniferous period, a world over 300 million years old. The layers of shale were rich with fish and jellyfish, traces of long-extinct creatures that had once filled the ancient oceans. But among them was one shape that made no sense. It was a long, flattened body with strange fins and a dark, segmented stripe down its middle. At one end, a round structure that looked like an eye. At the other, a curved tail like a ribbon. It was nicknamed the Tully Monster, after the amateur fossil hunter Francis Tully, who brought it to light. When scientists first examined the fossil, they were baffled. Some called it a worm, others thought it might be a mollusk. A few proposed that it was an early vertebrate, a creature with a primitive backbone. Yet each theory fell apart under scrutiny. The fossil had no bones, no clear organs, and no modern relatives. It was a creature out of context, as though nature had made it once and never again. In museums, the Tully Monster became a curiosity, displayed behind glass with labels that said unclassified. Paleontologists studied its odd tubular body and its peculiar appendage, a long stalk ending in a jaw-like claw, but no one could agree on what it was. For decades, it stood as one of evolution's great mysteries, a living contradiction trapped in stone. As technology advanced, so did the investigation. In the early 21st century, scientists began to apply new tools to old puzzles. Powerful scanning microscopes could peer deep into the structure of fossils at a molecular level. Spectroscopic imaging could detect traces of ancient pigments, proteins, and minerals that once formed living tissue. The hope was that these tools could finally reveal what kind of animal the Tully Monster had been. When the first detailed scans were made, the results were astonishing. The creature's body was far more complex than anyone had imagined. What appeared to be an eye was in fact two small carbon-rich spheres sitting on stalks' eyes containing melanosomes, the pigment granules found in animals with vision adapted to daylight. That alone ruled out simple worms or slugs. But the real breakthrough came when researchers discovered a thin, continuous structure running down the fossil's length, a notochord, the flexible rod found in all vertebrates, from fish to humans. The Tully Monster, it turned out, was not an invertebrate oddity. It was a distant cousin of fish, an ancient, soft-bodied vertebrate that lived in shallow, oxygen-poor seas more than 300 million years ago. Its bizarre anatomy, its jawed proboscis, its side fins, its long tapering tail were adaptations for hunting in murky waters where sight was limited and speed meant survival. It was not an alien, though it might as well have been. It belonged to one of the earliest and most unusual branches of the vertebrate family tree. The discovery stunned the scientific world. For decades, researchers had argued that such a creature could not exist. Vertebrates, they believed, evolved rigid skeletons early to support complex movement. Yet here was proof of a vertebrate with no bones at all, a soft-bodied hunter gliding like a ghost through the ancient sea. It forced scientists to rethink what it meant to have a backbone. Evolution, it seemed, had more than one way of building a predator. Further chemical analysis deepened the mystery. Using synchrotron X-ray spectroscopy, researchers examined the distribution of trace metals in the fossil. What they found was astonishing. Traces of zinc, copper, and iron in the same patterns found in modern animals' nervous systems. It meant that the creature's neural tissue, its brain and sensory organs, had been preserved in exquisite detail, something almost unheard of in fossils this old. For the first time, scientists could reconstruct how this creature might have perceived its world. The Tully Monster's eyes, rich in melanin, suggest that it could see in dim light but not in total darkness. Its flexible stalk allowed it to reach forward and grasp prey hidden in silt. The jawed appendage at the end of its snout was lined with small, recurved teeth, tiny but sharp enough to pierce the soft bodies of ancient worms and crustaceans. Its fin structure indicated that it moved with slow, undulating motions, gliding through the shallows like an eel. It was, in every sense, a predator silent, precise, and efficient. For years, artists had drawn the Tully Monster as a harmless oddity, a floating worm with a curious face. Now, with new data, a different image emerged. It was not a passive drifter but an active hunter, a creature perfectly suited to its strange environment. Its body was soft yet agile, its long snout a weapon for ambush. The fossil that had once looked absurd now made perfect sense. The revelation also solved another long-standing puzzle. The rocks in which the Tully Monster was found belonged to a unique formation called the Mason Creek Lagerstätte, one of the world's most extraordinary fossil sites. The conditions there, rapid burial in fine sediment and iron-rich waters, had preserved not only shells and bones but also soft tissues. This meant that creatures like the Tully Monster, normally lost to decay, could survive in stone. The site captured a moment in time when evolution was experimenting wildly with form and function, producing creatures that seemed both alien and familiar. The new understanding of the Tully Monster also reshaped how paleontologists think about early vertebrate evolution. It showed that the transition from soft-bodied chordates to bony fish was not a straight line but a web of experiments. Some species developed bones early. Others, like the Tully Monster, remained flexible and adapted in different ways. It revealed that the earliest vertebrates were far more diverse than anyone had realized. Yet even as the answers came, the mystery deepened in another direction. Chemical tests revealed that the Tully Monster's tissues contained traces of unusual organic compounds, molecules not typically found in vertebrate fossils. These compounds, related to keratin and preserved proteins, hinted at a unique chemistry, a way of building soft tissue that may have vanished with its extinction. In a sense, the Tully Monster was both ancestor and anomaly, a creature that fit within the vertebrate tree, but also stood apart from it, a branch that ended before others began to rise. The more scientists learned, the more they realized that the Tully Monster's story was not just about one species, but about the nature of discovery itself. For decades, it had been a symbol of frustration, a reminder of how incomplete our understanding of the past can be. But technology changed that. What once looked like chaos became pattern. What once seemed alien revealed deep connections to life still thriving today. New imaging tools have continued to refine the picture. Researchers have used three-dimensional reconstruction to model the creature's muscles and fins, revealing how it could twist and maneuver in water. Simulations show that it could accelerate in short bursts, its body bending like a whip to strike at prey. The sail-like fins near its head may have helped stabilize it, preventing it from rolling as it swam. Every feature, once inexplicable, now tells a story of adaptation. The discovery has inspired a new generation of paleontologists to revisit other problem fossils, long dismissed as unclassifiable. Some are now being re-examined using the same methods that solved the Tully Monster mystery. With each analysis, more creatures are being restored to their rightful place in the tree of life. The message is clear. What seems alien today may tomorrow reveal itself as part of the same grand continuum of evolution. Still, there is something poetic about the Tully Monster's long journey from mystery to understanding. For 50 years, it existed as a question without an answer, a fossil too strange to fit any box. It haunted textbooks and museum exhibits, a relic from a world that seemed utterly disconnected from our own. And yet, in the end, it turned out to be one of us, a vertebrate, a distant ancestor whose DNA, in some faint way, still echoes in every living creature with a spine. Its story is also a lesson in humility. Science thrives on certainty, on classification and order, but the natural world rarely cooperates. The Tully Monster reminds us that nature is messy, inventive, and full of surprises. Evolution is not a straight road but a labyrinth of paths, some leading forward, some ending abruptly, all weaving together into the vast history of life. Today, the fossil that once seemed alien has become an icon of scientific persistence. Its image is used in museums and research papers as a symbol of how technology can bridge the gap between mystery and knowledge. It stands as proof that even the strangest forms of life can find their place in the grand pattern of evolution. And yet, even as its identity has been solved, the sense of wonder remains. When you look at the fossil today, encased in its ironstone nodule, you can still see the faint, dark outline of its body. The stalked eyes, the long snout, the delicate fins all preserved with eerie precision. It is a snapshot of a world long gone, a glimpse into the moment when life on Earth was still experimenting with what it could become. Scientists continue to debate the finer points. Was it a distant relative of lampreys, the jawless fish that still swim in today's oceans? Or was it a unique branch that evolved separately and left no descendants? Even with all the technology in the world, some questions remain tantalizingly open. The fossil speaks, but it also keeps secrets. In the quiet halls of museums, under bright white lights, the Tully Monster rests. Visitors pass by, some staring for only a moment, others pausing longer, drawn by its strange beauty. It looks simple at first, just a dark impression in rock, but the longer you look, the more unsettling it becomes. There is something haunting in its form, something that whispers of distant oceans and forgotten worlds. What makes it extraordinary is not just its shape, but its story. It is the story of how mystery drives science, how curiosity bridges millions of years, and how even the most alien forms can reveal the shared patterns of life. The Tully Monster is no longer a question, it is an answer, one that reminds us that truth can be stranger than imagination. Modern scientists call its discovery a triumph of interdisciplinary research, a collaboration between chemistry, physics, and paleobiology. But beyond the data lies something more profound. The fossil is a bridge between times, a message from a world when life was still deciding what it wanted to be. Every new technique, every scan, every molecule measured pulls another thread of meaning from the stone. The once unsolved creature now stands as a symbol of perseverance. Its journey from mystery to understanding mirrors humanity's own journey through knowledge. For 50 years, it challenged scientists to look closer, to think differently, to question what they thought they knew. And when the answer came, it was not simple, but beautiful. The Tully Monster was never from another planet. It was born in the same seas that gave rise to all vertebrates, shaped by the same ancient forces that still shape life today. Its strangeness was only a reflection of our limited view, our inability to see the full complexity of evolution's experiments. In the end, it was not the fossil that was alien, it was our understanding that was incomplete. The mystery is solved, but the wonder endures. When paleontologists finally placed the Tully Monster in its rightful place on the Tree of Life, they did more than identify a species. They reminded us that Earth's history is filled with marvels we have yet to imagine. Somewhere in the rock, beneath layers of time, there are still other shapes waiting to be found. Other creatures that will force us to rewrite what we know about life itself. The Tully Monster's eyes once looked out into an ancient sea filled with creatures long vanished. Now, through its fossil, it looks at us across the gulf of time. It reminds us that the line between alien and familiar is thin, that the world has always been stranger than we think. And perhaps, in the silent shimmer of its preserved form, we see not just the past, but the endless curiosity that keeps us reaching toward the unknown.